pressed the right one. Alrighty. So how do we go about naming our ionic compounds? Well, we have an order. We always name the cation first, and I did say this to you last time. So for example, sodium chloride. The sodium here is the cation Na+. And so the anion is named second, which is obviously then our chloride ion. So that's the first rule, is the positively charged one is named first and the negatively charged one is named second. Okay, rule one. Rule two. Our cation doesn't change its name. So this was sodium metal before it reacted, it's still sodium as the ion. So the important thing to look at there, to note, is that the name part hasn't changed. I'm just telling you that this is the metal and this is the ion, but you wouldn't normally write it that way. Now, our third rule, the anion frequently changes. Frequently changes to end in "ide". So oxygen then becomes oxide. Chlorine becomes chloride. Let's go with what else? We don't really use the metal hydrides much, so so we're ending in "ide", and that's a clue then when we read the name here, we know it's not just an element anymore because there's two names, but we know that what we've got present is the ion, the chloride ion, because it's in the name, sodium chloride. With our metals though, so I'm going to have rule 4. This is for metals with multiple oxidation states. Group 1 metals can only form a single positive charge. So this rule doesn't apply to them. Group 2 metals can only form two positive charge. So this rule doesn't apply to them either. This rule is applying to transition metals. Okay, we can form multiple oxidation states. Now I know we don't actually study the chemistry of transition metals, but this might help you when you're looking to see, well, where am I going to find these? Heavy metals as well can also form. So, say for example. But our important one that you're going to strike a fair bit would be that we have Fe2 plus and Fe3 plus. As this iron is a transition metal, and it can form these two ions that are both positively charged. So how do we tell the difference then between them if we've got a compound, just say I've got iron oxide. If I just wrote iron oxide, I wouldn't know which one it was. And so the way we get around this is by using Roman numerals. So our example here for iron oxide would be, so if I write iron 2 oxide, so with the Roman numeral 2 in brackets after iron, I know it's Fe2 plus. And then I can then write FeOH2, like that. We'll get to this bit in a moment. And then iron 3 oxide will be FeOH3. So we need to be careful that we're keeping an eye out for some of these metals that can form multiple charged ions. On your formula sheets, lead's another one. I'm pretty sure you've got tin on yours as well. After a while, the chemistry and phys formula sheets start to merge.
Is it what you've written there, iron oxide and then iron hydroxide? Is it iron
Oh,
oxide?
yeah, sorry, I have. Right, thank you. Someone's awake. It's not me. Yes. That is right. So the point here, we need to make sure that we've got our Roman numerals in brackets to distinguish between the possible oxidation states of those particular metals. There's something else I wanted to...
So is it now just Fe? O?
Yeah.
Okay.
Yeah. The other rule, so the rule 5 if you like, is that we just say what is present. So see how here, for the written name, see in this name, it's sodium chloride. There's sodium present and there's chloride ions present. Here, iron oxide. Now, in here, there's no indication of how many. we had to balance it, or I had to balance it as the chemical formula, but we don't write anything in the name to say how much is present. So and then for example then, if I had magnesium chloride, I'm just saying what's present, but then when I write the formula, I have to make sure I balance the charges. Okay, see how this name here for magnesium chloride is the same as for the sodium chloride, and the same for the iron oxide, just saying what's present, not giving any indication of proportions within the compound in the written name. Do you understand what I'm saying there? Yep. And yeah, so this is how we go about naming it. But our next step then is to write formulas, which I've sort of started doing here. But that will do us for our naming. I'll just stop there.